In this video segment, we are discussing analog inputs and outputs. In addition to having digital I/O, PLCs also utilize analog inputs and outputs. With digital inputs, we can only have two states, on and off. But what happens if we need to represent a value within a range? Sensing temperature is a good example of how we represent a value within a range and bring it into the PLC as an analog input. In this example, we're showing an analog circuit that includes a power supply, an analog device that is capable of producing a value from a range of values, and a resistive load. Let's now apply how that circuit relates to analog inputs in the PLC. In this case, we're using a temperature sensing device that is capable of sending a value to the PLC that will be within a range of negative 40 degrees F to positive 120 degrees F. But the device will represent the temperature as a current range from 4 milliamps to 20 milliamps. So, when the device is sending 4 milliamps, it will be seen in the PLC as negative 40 degrees. And when the device is sending 20 milliamps, it will be seen as plus 120 degrees. And then right in the middle, when it's sending 12 milliamps, it will be seen as plus 40 degrees. The correlation or scaling between the signal and the actual temperature is done in the PLC. 4 to 20 milliamps is a common way to send a value within a range. 0 to 10 volts can also be used, but is more susceptible to noise and distance limitations. RTDs and thermocouples are examples of analog devices that send temperature signals into the PLC and typically require no scaling. Examples of analog input devices are flow transducers, load cells, which indicate weight, and pressure transducers, which could indicate the level in a tank. There are a number of ranges associated with current and voltage signals. Just like the difference between digital inputs and analog inputs, it is sometimes necessary to have more than just on-off control of an output device. In some situations, it may be necessary to open a valve at 30% or 70% over a range of completely closed or open. This is especially true when controlling a motor with a variable frequency drive that can run from 0 to 60 Hertz.